Okay, so for this section, we're going to talk about quadratic functions and their properties. So there's two types of equations we're going to be exploring. One you're familiar with, which is the standard form, which is f of x is equal to ax squared plus bx plus c. And then you have the vertex form. F of x is equal to a times x minus h squared plus k. So we need to learn how to use both of these equations, and we need to go back and forth and learn how to write one and vice versa. Okay. So here you have a quadratic function or a parabola, and at the either at the the bottom, the minimum or the maximum is called the vertex. And then if you draw a line all the way down the center, that's called the axis of symmetry. Okay. And for these particular problems, we want to graph the function, find the vertex, as well as the axis of symmetry. Okay. And then we'll also find out why, when we're moving left to right, why is it the opposite? Okay. So when we look at this, and again, all we're doing here is we're just sketching this. Okay. So the first one is we have f of x is equal to x plus 2 squared minus 2. And the vertex is dealing with hk. Okay. Hk. So what is HK? So if you look at here, right, the vertex form, right, because this is all in vertex form, um, HK is dealing with the vertex. So in this case, remember x plus 2, when we graph that, the positive 2 means we're actually going to the left, correct? So plus 2 here in the parentheses, I go to the left, and then minus 2 means I go down. Right? So again, in the parentheses, it's always the opposite of what we think. Plus 2 means we're actually going to the left instead of going to the right. So here on my X and Y plane, I'm going to graph the vertex. So remember, that's just the lowest or the highest point of the graph. So 1, 2, and then down 2. 1, 2. So there's my vertex, right? So and that also tells me what my H and K are. My H and K is going to be -2 and -2. That's my HK. Okay. All right. So now we also need to figure out, well, is this going to be a happy parabola or a sad parabola? So in this case, if we look in the front, we have a positive number there, right? It's a positive 1. So in this case, this is a happy parabola. So again, I'm just sketching this. It doesn't have to be super exact, just a sketch. And then that's my parabola. Okay. And my vertex is right here, this point. Okay. So the axis of symmetry, okay, is the same thing as the x coordinate, or in this case, the h part of the vertex. And I have to write it as an equation. So that's going to be x is equal to, in this case, -2. Okay. So the axis symmetry is splits the graph in half, or it's sometimes called the reflective line. Write that down here. Reflective line. Okay. So this is going to be x is equal to -2. Okay. All right. So we graphed the function, we identified the vertex, and then we also identify the axis of symmetry. All right. Let's try another one. So this one is f of x is equal to x minus 3 squared plus 1. All right. So again, it wants us to find the vertex and the axis of symmetry. So remember, the vertex deals with hk from the vertex formula. All right. So we want to locate the h and k. So the h and k is a -3 and 1. But in this case, it says a -3. So normally we would think we would go to the left, but we're actually going to go to the right. Okay. The opposite of what we think. So it's going to go to the right, 1, 2, 3, and then you have plus 1. You go up 1. right? And again, the top, I mean, the coefficient here is 1, it's positive. So that means we're going to have a parabola that's again going up. So again, we just want to sketch 3, 1. All right. And then, so then I just write down what my H and K are. That will be 3, 1. And then my axis symmetry is X is equal to, again, it's always the H value of the vertex. And that would be 3. Okay, so for the last one, um, we have f of x is equal to negative of x minus 4 squared minus 3. So I want to identify um, my h, k, my vertex. So that's going to give us at 4, 4, negative 3. Okay, so then I just plot that. So 1, 2, 3, 4, and then I go down 3. 1, 2, 3. So 4, negative 3. Okay. And then the axis symmetry is the h value. So that's going to be x is equal to 4. All right. And this time we have a negative in the front. So it's a negative 1. So that means our parabola is going to be going down or it's going to be sad. Okay. All right. So I mentioned that I was going to explain why it's the opposite. Why do we go the opposite in when we go left and right? So if you look at back at this vertex form, right? We have x minus h. That's the formula. So if I put, so notice here for this first one here, okay, we have a plus 2. Well, in order to get a plus 2, when we look at a vertex, we have a negative 2. So when I plug in negative 2 in here, I get a minus negative 2. So when I plug this back into the formula, the vertex form, it spits out a what? A positive 2. Okay, and that's the reason why it's the opposite, because of the vertex form. All right. Um, for these other ones, they're fine because I just plug in 3, I get the x minus 3, and I plug in 4, and I get the x minus 4. Okay. But anyway, that's the reason why it's the opposite, is because of the form. Okay. All right. Let's move on to the next question. Okay, so this form, when we convert this from standard form to vertex form, we have to think about balancing it. So if we have 5 to get a 0, we need to add a negative 5. Again, if we have 7 to get a 0, we add a negative 7. And vice versa, if we have a negative 8 to get a 0, we need to get a plus 8. So we need to think about this as we go through this process. And this process is going to be similar to completing a square. Okay, so we need another formula, and that's going to be the b over 2 square as well. Okay, all right, so what do we do? Well, the first thing we need to do here is we need to separate. So remember, in standard form, you have the ax squared plus bc. So 1 is our a, b, it'll be our 4. I mean, 4 is our b, and then 2 is our c. All right, so that's your ax squared plus bc. ax squared plus bx plus c. So what we need to do is we need to separate these two terms to the left. We're not moving it on the other side of the equal sign, stays on the same side, okay? And then move this c to the right, okay? That's the first step. So again, f of x is still on the left side. Okay. So we're going to separate that. That's our first step. So we have x squared plus 4x, and then we have a plus 2 here on the right. And what we're going to do is we need to use this formula, the b over 2 square, as we used it in completing the square, um, to identify what we need to add. Okay? So in this case, we have b, which is 4. So we're going to have 4 here divided by 2 square. 4 divided by 2 gives me 2. Then I square that will give me 4. Okay? So what does this mean? Well, this means then, again, my goal is to write the standard form and convert it to vertex form. Okay? So notice that this is an x minus h squared. So that means I need two factors that are the same. So that's what I'm trying to do, is I'm trying to find two factors that are going to be the same. Okay? So I need to use this formula, the b over 2 squared, in order to do that. So in completing a square, we normally would add the box on the right side of the equation and then also on the left side of the equation to balance the equation. But in this case, we're going to have it on one side. So what do I mean by that? So I'm going to have, so I'm just going to write this in a different color. All right, so I'm going to have add a box here. Okay, and I need to add a box here. Okay, so in this case, what goes in that box? Well, what we found out from b over 2 squared, all right, 4. So I'm going to put 4 in here, okay? However, for this box, do I also put a 4? And the answer is no, because again, we need this to be the same as the previous step. So instead of adding a positive 4, we need to add a negative 4, okay? So they basically cancel each other, right? Because we need to preserve, because this step here has to be the same as this step here. They're equal. So if we add and didn't change the negative 4 here, then they're not going to be equal anymore. So we need to be sure that they are equal. And so that's the biggest difference between completing the square, which we originally do, and then trying to convert this to vertex form. Okay? Okay, so now once we have that, so again, we're going to separate the A and B terms from the C term. We use the formula B over 2 squared to find what we need to add. One has to be positive, the other one has to be negative in order to have it equal on the previous step. So now what we do next is we need to factor. Okay, so we have x squared plus 4x plus 4. So that's going to give us x plus 2 times x plus 2. And then here it's going to be what? 2 plus negative 4 is going to give me a negative 2. So that's just going to be a minus 2 there. Okay? And then I rewrite this. This is what I want. I need two factors to be the same. So this becomes x plus 2 squared minus 2. Okay? So notice now we have this is in vertex form. This here is in vertex form. Okay? So we had it in standard form. Now it's in vertex form. So again, we needed to be over 2 squared in order to do that. All right? So that's what they want first, is we need to write it in vertex form. And then the rest we've already done. So we need to graph the function, identify the vertex or the max and minimum point, and then the axis of symmetry. So go ahead and do that part. All right, so again, first thing when we do a sketch of this, we identify the vertex, HK. So remember, we always go the opposite um, of this. So we go -2 to the left, and then down 2, right? And then we have a +1, so that means we're going to have a happy parabola, okay? So I write down our HK, which is -2, -2, and then our axis of symmetry is just the H value, right? Which is x equals, excuse me, -2. Okay. So, okay. So again, the first thing we need to do is we need to separate these first two terms to the left and then separate that to the right. Okay. So we have x squared plus 2x minus 8. Then we're going to use the formula b over 2 squared, right? So b over 2 squared. So our b in this case is the 2. So that's going to be 2 over 2 squared. So that's going to give us 1 squared, which is 1. Okay. So we're going to add 1 here. So again, we add a box and then we add another box. So we're going to add 1 here. But in this case, to balance this, this has to be a negative. So we subtract a 1. All right. So again, this is all still on the same side of the equal sign. Once we do that, then we just factor and simplify. So on the left side here, we're going to have x plus 1 times x plus 1. That's our factors. And then -8 plus -1 is going to give us a -9. Okay. So this becomes x plus 1 squared minus 9. So this is our vertex form. Okay. All right. So now when we graph this, okay, we want to graph the h and k. So in this case, h and k, again, which is the vertex, that's going to give us -1, -9, right? So again, always opposite of what you think. So +1 is actually -1, so we go to the left, -1, and then down 9. All right, so let's just say this is down here, -9. So it's somewhere down here, okay? So, and then we still have a happy parabola. So we draw our happy parabola there. And then our axis of symmetry is going to be x equals -1. Okay. Okay. So this one is a little bit different, but the process is still the same. Okay. So here we're going to take these two terms here and move it to the left. Let me rewrite that. So 2x squared minus 4x, and then move this one to the right, giving us 1. Okay. So remember, in completing the square, the leading term has to be a +1. So these previous problems we did were great because we had a +1, okay, and we had a +1. So they're all great, okay? But in this case, we don't have that. We have a +2. So but we have to keep it in that form where the leading term is 1. So what do we do? So again, this is still on the same side of the equation. So normally in the completing the square on the other one, we would divide by 2 everything and everything's dandy. But in this case, we can't do that, okay, because we're not going to divide f of x by 2. Okay, so so what we need to do is we need to factor out a 2. So this becomes 2 times x squared minus 4x, sorry, minus 2x, and then give myself some space. I still got the +1 here to the right side. All right. And then now I can use the formula b over 2 squared. But I have to be careful because now instead of using this b, we have to use this b. Okay? So we're not using the original b, but this b here in the parentheses. So be careful with that. Okay? So we want to use, let me circle that, this one here for our b, not the one here, not this one. Okay? All right, so this is going to be negative 2 divided by 2 square. So that's negative 1 square, which is a positive 1. Okay. So we're going to add a positive 1. So, okay. So, um, as I mentioned, this top equation has to equal here. And if we just add in the minus 1, when we distribute this to each term, we get 2x squared minus 2x plus 2, but plus 1 minus 1 will give me a 0. So this here is not the same as above. So what do we need to do? Well, we need to factor in that we had factor out that 2. So in order to balance what we have on this side of the equation, all right, we have to multiply this 1 by 2. So if we multiply this 1 by 2, we get a positive 2. So instead of adding a negative 1, we add a negative 2. So that becomes 1 plus negative 2, which becomes a, uh-oh, what happens there? Oh yeah, that's fine. We get a negative 1 because 2 plus negative 1 is a positive 1. All right, we're good. All right. So this is going to be the same. This is going to be a 4x. Goodness gracious. Minus 4x. That's going to be the same as the one up here. Okay. All right. So let me reiterate that real quick here from this example. So again, if we had a 3 in the front, if we had factored by 3, and we were adding a 1 in the middle inside the parentheses, then we have to factor in the 3, so it'll be 3 times 1, and then add the opposite of that here to balance it out, giving us negative 3 here. Same thing for this. If we had a positive 2 in here, we have to factor in that 3, so 3 times 2 is 6. We would add the opposite of that would be minus 6. Okay, so again, the key part is making sure that we factor in that 2, which we had factor out originally. Okay. All right. So okay, um, so when we got here from our formula b over 2 squared, we got a 1, so we're going to add a 1 here. So as I mentioned, we can't just add a negative 1, right? We can't just add a negative 1 because it doesn't balance it when we work this out to be the previous line. It doesn't equal this up here. So what we need to do is we need to factor in this positive 2 that we had. So that's going to be 2 times 1. So that will give us a 2. 2 times 1 is 2. So that means then we would add a negative 2 here to balance it out. Okay. All right. So in this case, we'll have 2 times x. Again, we got negative positive, so that means both our factors are going to be negative. Okay. And then 1 plus negative 2 will give us a minus 1. Okay. So then this becomes 2 times x minus 1 squared minus 1. So this is going to be our vertex form. Okay. Then we just draw this, right? So we have negative 1, so that goes to the right 1 and then down 1. Okay. So that's going to be where our vertex is. And then we have a positive 2 here. So that means that it's going to stretch it out by a factor of 2. So, something like that. Okay. So there's our graph. And then our vertex is going to be HK, which is positive 1, negative 1. And then our axis of symmetry is going to be x. X equals positive 1. Okay, so for this problem here, your goal is to find A. So goal is to find A. Okay. And then once we find A, we can write our final answer in vertex form, which is in this form right now. Okay. And then we're going to um, rewrite it as in standard form. Okay. So it looks complicated, but it's actually not that bad. So first we need to identify what these points are, right? So vertex, that's going to be our H and our K. We talked about that extensively. And then the y-intercept that they gave us, that's going to be our X and Y values. Okay? So they gave us the vertex and the y-intercept. So this y-intercept here is just going to be our X and Y value, right? And then we plug everything in. So remember f of x, another way to say f of x is y, okay? And then we just plug in all the information. So y in this case is negative 1. A, I don't know. That's what we're looking for. X is 0. Minus h is negative 1 square. And then plus k is negative 2. Okay. So again, they give us all the information. We just need to plug it into the vertex form and find A. Okay. All right. So um, now we just simplify. So this is going to give us a positive 1, right? So A times 1 square plus a negative 2. So that's going to be 1 square is 1. 1 times A is just A plus a negative 2 minus 1 here on the right, left. Then we're going to add 2 to both sides. So that gives us 1 equals A, right? So we found our goal, A. Once we have A, then we plug it back in to the original, okay? So in this case, we're going to have f of x equals 1 times, I'm going to put that in blank for right now in the parentheses, square, all right? And then our k there is negative 2, right? And then we have x here. Now, we have to be careful here because this is a minus h, okay? So so that means then we have to have the opposite, correct? So in this case, I need a positive 1, right? Because remember, when I graph this, it'll be negative 1 going to the left and then down 2. So that's the tricky part, is even though it says negative 1 here, but I put it in the equation, the vertex form, it has to be a positive 1. Because when I graph it, I get to negative 1, then down 2. All right, so here's our vertex form. That's what they want. Check. Okay. Now, let's rewrite this now into standard form. So let's rewrite it in standard form. Right? So which is the ax squared plus bx plus c. And that's not too bad, right? So we have x plus 1 squared minus 2. So we'll have, let me use a different color here. So we have f of x, and then we have the x plus 1 squared minus 2. So let me write that here. Okay. And then x plus squared minus 2, we just expand that. So x plus 1 times x plus 1 minus 2. Then we just FOIL this out. So remember, one little trick is you can just square the front, square the back, multiply the two terms, and double it. Or you can FOIL it out. Okay? So either way, you get the same answer. So square the front, square the back, multiply the two. So that's 1 times x is 1x. Then double it, 2x. All right, and then the minus 2. So in this case, we get x squared plus 2x minus 1. All right, so our standard form is going to be x squared plus 2x minus 1. So this is in standard form. Okay, and this here is vertex form. Okay, so in this case, again, it wants us to determine without graphing whether the given quadratic function has a maximum value or a minimum value, and then find the value. So the key to this problem is using the formula, which we've used before, x is equal to negative b over 2a. So remember, we talked about this, finding the maximum revenue, all right, in the previous one, but you can also find the minimum. Right? So we need this particular format to do that. All right. So first we need to identify our letters. So this is our A value, here's our B value, and then here's our C value. Okay. And then we just use this formula. So we plug it in. So again, we're trying to find that maximum or minimum value. So B in this case is 12. So we'll have negative 12. And then 2 times A, which is just 2. So you have negative 12 over 4, which gives us a negative 3. Okay. So that's where the x, right? The x where the axis of symmetry, the line of reflection, is going to be as x equals negative 3. So then we need to find out what is that value at x equals negative 3. So that means then we need to plug in that value, or this x number, into our function. Okay, so we're going to have f of negative 3 equals 2 times negative 3 squared plus 12 times negative 3 minus 3. All right, so this one gives us 9 times 2 is 18. This is going to give us minus 36 and then give us a negative 3. So in the end, when we compute that, that gives us negative 21. All right. So now we need to figure out, all right, is this a maximum value or a minimum value? Well, let's look at our parabola, right? So in this case, we have a positive 2. We have a positive 2, that means we have a happy parabola, right? It's a happy parabola. So if it's a happy parabola, okay, that means this is a minimum, okay? So this is a minimum, right? This is a minimum value, okay? So what did we just calculate? We wanted to well, this point here, right? That's what we just calculated. That point is at negative 3, negative 21. That's the point we just figured out, the vertex. And what we want is the value. When they're asking for the maximum value or the minimum value, they want the y value. They want this one. Okay? So they just want this value here. All right? So again, when it's asking for the maximum value or minimum value, you want the y coordinate. You want the y coordinate. Okay, that's what that means. So in this case, that y coordinate is negative 21. Okay, and then we have a minimum at negative 3, negative 21. Okay, all right. Okay, so it's a different color here. All right, so for this one, again, we're going to be applying the same thing as the same formula as we did before. X equals negative b over 2a. So let's write that here. Okay. So again, we identify where our A and B, C are. Here's our A, here's our B, and then here's our C. And then we plug it in. So we got negative 12, and then 2 times negative 3. So that's negative 12 divided by negative 6, which gives us a positive 2. Okay. Then we plug in that value in our f of x function. So f of positive 2. So we get negative 3 times 2 squared plus 12 times 2 plus 1. Okay. So that gives us negative 12 here, a positive 24, and then a positive 1. So we simplify that and we get 13, right? Now we have to identify whether we have a minimum or maximum value. How do we do that? We need to look at the leading term. So negative 3 is our leading term, or in this case, the leading coefficient. And so that gives us a sad parabola, right? That gives us a sad parabola. So a parabola going down. So that means then we have here our vertex, right? That's what we just calculated. The vertex is at 213. That's the highest point. But the maximum value, we're going to have a maximum value at y is equal to 13. Okay.